Today we're going to take a look at perpendiculars and distances, more specifically the distance between two parallel lines. So we're given two lines. I want to find those distance. I'm going to plot them, and then I've got four rules that are going to kind of help us get there. So first thing I want to do is graph and find my new slope. Find our new perpendicular slope. Then I want to figure out what my y-intercept is, and then I want to create an equation. So find y-intercept and new equation. Once we do that, it's fairly simple, but it's just a lot of work. System of equations and distance formula. All right, so we know what we're doing. Let's just go and do it. Let's plot first. Down 3, we're going to go up 3 over 1, up 3 over 1. There's one line. This is line L. Second line, line M, we're going to go up 4. We're going to go up 3 over 1 off our graph. We can go down and back, and we can do that one more time. And that is line M. Fine, we graphed it. What's our new perpendicular slope? Well, first off, these lines appear to be parallel. Are they? Well, look at their slopes. They're both the same. Yes, they are. Cool. So our new perpendicular slope is going to end up being two changes, opposite and reciprocal. Opposite, positive to negative, reciprocal, 3 to 1 over 3. We have that. First one, done. Find the y-intercept, and we're going to find a new equation. Find the y-intercept. Hey, there's a y-intercept. Let's use that. That is 0, 4. Now, what's so special about that? Well, I could take that coordinate and that and plug it in the y-intercept, y equals mx plus b, but no, wait. Let's do less. I know that my y-intercept is just straight up 4. We have our equation done for us. Let's just plug them in. Y equals negative 1/3 x plus 4. What we just found was that we found the equation of this dashed line. It's perpendicular to both of these. Why perpendicular? Because perpendicular is going to give us the shortest distance between them. What we now need to do is create a system of equations. We want to figure out where two lines intersect. Line M and my dashed line, we know they cross each other at 0, 4. I want to figure out where this point is right here. So I'm going to take my new equation and equation L and solve a system. So equation L is going to give us, let's try a new color now, 3x minus 3 equals negative 1/3 x plus 4. Set them equal to each other. Now let's solve. I'm going to say add 1/3 x, add 1/3 x. We're left with 3 1/3 x. We'll come back to that. Add 3 equals 7. Let's change this. I don't like the way that looks, so we can multiply and then add, giving us 9 and 1 gives us 10 over 3. We just went from a mixed number to an improper. And why? Because if I multiply by my reciprocal, 10s, 3s cancel out. On the other side, x equals 21 over 10, which is the same as saying 2.1. Okay, that's good, but it's only half of our work. We just found that. We still need to figure out what the y half is. So what do? I want to take this 2.1. Let's plug it back into one of our equations. Okay, so I'm going to plug it into line L. Why? Because there's no fraction. So let's use that. We're going to say y equals 3 times 2.1 minus 3, giving us 6.3 minus 3, which is the same thing as saying 3.3. There's your y, 3.3. We now know that this is 0, 4, and that this point right here is 2, 1, 3, 3. It's ugly, but it's still a point. I want to use those two coordinates and plug them into my distance formula. Last big step that we have to do. So we now say d equals the square root x2 minus x1. So we're going to say x minus x. 2.1 minus 0. Square it plus 3.3 minus 4. Square that. D equals square root 2.1 squared plus negative 0.7. So yeah, plus negative 0.7. That gets squared, giving us right here. So 21 is 4.41 plus negative and negative turns to a positive. 7 and 7 is going to be 49, so 0.49. Add these two things up, giving us d equals the square root of 4.9. And the square root of 4.9 is something, I don't know, whatever that's going to give you. Plug that into a calculator. And that then tells you that to that. And that's finding the perpendicular between two parallel lines with whatever this is.